Let's quickly give a quick preview of how the scikit-learn library works before we actually open up a notebook and get started with it. As I mentioned, we're going to be using the scikit-learn package in order to do some machine learning in this course. It's the most popular machine learning package for Python, and it has a lot of algorithms already built into it. If you aren't using our provided environment file, you may need to install it using either conda install scikit-learn or pip install scikit-learn. So go ahead and make sure you've installed it before you hit the next lecture. Let's quickly talk about the basic structure of how to use scikit-learn. First, a quick review of the machine learning process. Remember, we need to acquire our data, clean our data, split our data into a training set and testing set, test the model on the test set, and then we can go on to model deployment. So what we're going to do now is show you an example of this process using scikit-learn's Python syntax. And don't worry about memorizing any of the steps. We're going to get plenty of practice and review when we actually start coding in subsequent lectures. Every algorithm is exposed in scikit-learn via what's known as an estimator object. Estimator is really just another word for model, since all machine learning models are doing are estimating to a predicted output. So first you're going to import the model, and the general form looks something like this. You say from sklearn dot, and then the family of models you're looking for, and then you import the actual model. For example, if you wanted to work with the linear regression model, you would simply say from sklearn dot linear underscore model, and that linear underscore model is the family of linear models. Then you would import whatever specific model you're looking for. And we'll show you using the Jupyter Notebook. You can use tab and shift tab to quickly see what models are available. Keep in mind, each estimator or machine learning model has parameters, and all the parameters of an estimator can be set when it is instantiated and have suitable default values. So luckily, you don't need to know too much about the actual algorithms before you get started with scikit-learn because they usually have pretty reasonable default values. And again, you can use shift plus tab in Jupyter to check the possible parameters. For example, we could create a linear regression and state that the normalized parameter is equal to true. And then if you print out the model, you'll actually see the various other parameters, such as fitting the intercept. Once you have your model created with your desired parameters, it's time to fit your model, or train your model, on some training data. But remember, you should always split the data into a training set and test set. Lucky for us, scikit-learn comes with a train test split functionality. So we can say here, from sklearn.model underscore selection, import train test split. And then here, I've made up some data for X and Y. And then if you actually pass X and Y into train test split, all you need to do is decide what percentage of it should go to your test set. So the percentage is going to be between 0 and 1. So if I say test size is equal to 0.3, then that means 30% of this data will go to the test set. And notice how it brings back X train, X test, Y train, and Y test, just as we discussed in previous lectures. Now that we've split the data, we can train or fit our model on the training data. And this is done through the model.fit method. All you need to say is model.fit, pass in your X training data, and then pass in your Y training data. Now that the model has been fit and trained on the training data, the model is ready to predict labels or values on the test set. So you get the predicted values by saying model.predict, and then you pass in the X test set. And keep in mind, this .predict method is the same method you would apply for brand new data that the model has never seen before. So that's how you can use your model to predict on new values. So we can then evaluate our model by comparing our predictions to the correct values. The evaluation method depends on what sort of machine learning algorithm you are using, whether it's regression, classification, or clustering. In our case, we'll be looking at classification, so we've already gone over the different classification metrics. Let's go ahead and actually program through all of this in the next lecture. I'll see you there.